Number 18. So this one is talking about, we talk about gold, and its symbol AU. So hopefully you recognize that AU is gold. It's present in seawater to the extent of 0.15 milligrams of gold per ton of water. And then how many gold atoms are present in 3 times 10 to the second, that's what that means, 3 times 10 to the second grams of water. Okay, so anytime you do these kind of problems, you look for the question and you say, how many gold atoms are present in this? Okay, what this is telling you is 2 things. This is where you start. This is where you end. Okay, so we're going to start with 3 times 10 to the second grams. We'll just call it water. Seawater, water, I don't care. So that's where we're going to start. We start right here, and we're going to convert that to this. That's where we're going. Well, how do we do that? How do we go from water to gold? Well, that's why they give you this. Okay? So this gets you, that's your conversion factor. It's just like anything else. It's like taking you from inches to feet, or from, pounds to kilograms, or something like this. This is taking you from gold to water. Okay? Now, it's a bridge. I think of conversion factors as bridges. In order to use this bridge, we have to be in tons of water. Okay? Right now we're in grams of water. And they tell you 1 ton is exactly 2,000 pounds. So, we're going to go to tons. To get to tons, we got to go by pounds. So right now we're in grams. So, we have to know there are 453.6 grams of water in 1 pound of water. Okay. There are 2,000 pounds of water in 1 ton of water. And then, now we can use our conversion factor here. And in 1 ton of water, there are 0.15 milligrams of gold. Okay. So what does that tell us? Let me back up just a little bit. Before we go any further, in our problem it gave us, we have 2 numbers. We have this one, we have this one. Hopefully you recognize that this is something that came from data. Somebody measured that number, that it's something that is not a conversion factor per se exactly. So it's not an exact number. And so that's really, it's got 2 significant figures. This one has 3 significant figures. So our answer should have 2 significant digits, because that's as good as this number is. Okay, everything we're doing is going to be multiplying and dividing. So now we can forget about sig figs. We just remember at the end we have 2 sig figs in our answer. If you had 3, I wouldn't get mad at you. That's close enough. The important thing is don't have 20, okay? Don't have 7. It's either 2 or 3. Hopefully you recognize that it's 2. Okay. So we have 4.96. We're going to carry it out as 3 right now. It doesn't really matter, because in the end we'll fix it, right? Times 10 to the minus 5 milligrams of gold. That's what 300 grams of water, that's how much gold is in there. Okay, now we want to know how many gold atoms. So we're going from milligrams of gold to gold atoms. Remember mole island, so we go from grams to moles to atoms. There's no direct line from grams to atoms. So we have to get on the mole bus, we have to get on mole island. So there's 10 to the third, or 1,000 milligrams of gold in 1 gram of gold. then we can just use a periodic table. Gold is 197.0 grams of gold, 1 mole of gold. Excuse me, sorry. And then, like always, 1 mole of gold, there's 6.02 times 10 to the 23rd atoms of gold. So that gives us 1.52 times 10 to the 14 atoms of gold. Okay, that's what they asked for. We're in the right units, things cancel out. That's where we are. So our answer, we should, to be technically correct, it should be 1.5 times 10 to the 14. You can fix sig figs atoms of gold. Okay, so we started here with 300 grams of water. We went over our bridge and we got to from mass of water to mass of gold. Then we went to Mole Island. We went from mass, we got to the right units, we went to grams, we used molecular weight to get to moles. And then we got off the island and we got we went to atoms. Okay. That was our path. There's a lot going on. Again, last thing. Looking at the question, how many gold atoms are present in this many grams of water? This is where you start. This is where you end. That was where we started. This is where we ended. So that's how you approach these problems. All these other numbers that you see in the problem, we used at one point or another, but they were conversion factors. Okay, this is 1, this is 1. Okay, they got us from one thing to another. You never start with a conversion factor. Because frankly, there's a 50-50 chance that you start with your conversion factor upside down. Okay, so here we divided by 2,000. Had we started with 2,000, we never would have got the answer. There you go.